Being able to attend CppCon in person lets you interact with the presenters and to really get to experience the character of the presentations and to engage more with the subject matter than just reviewing it online after the fact.
Okay, so you know the builder pattern. It's good when you need the sort of flexibility that other languages get with named parameters, but it has the same problem as named parameters. The API doesn't encode any constraints on the values, any restrictions on what you can use together. So that's the problem I'm tackling here. This is the example we'll be working with. A plane must be constructed with a position, a size, and at least one passenger. And the caller must not specify position or size twice. The code snippet on the left will compile because it satisfies those constraints. The two on the right will not. The first one is missing set size, and the second one has two set positions. Now, you've got to validate your inputs. The easy way is for a builder to delegate that to the constructor. You might do some validation earlier. For example, if the caller sets the plane's position twice, but it's still at runtime. I will demonstrate validation at compile time. The brute force way to tackle the problem is to write one builder type for each combination of the "is this variable present" flags. The set position method would be defined only on classes for which position had not been set. But then you need 2 to the n types with n setter methods each. Not very scalable. The scalable approach is to write a template with 3 Boolean parameters: has position, has size, has passenger. Partial specialization lets us have a setter which returns a builder with the corresponding template parameter set to true. This gets us down to O of n. Back to our example. We want to build a plane object. Position and size must be specified exactly once, and it must have at least one passenger. Here we have the template for the builder. It's got a build method, which is delegated to the build t struct, and a constructor. The constructor really ought to be private, but I had to simplify for the slides. Here we have the builder set methods, which delegate to set structs, which then get specialized. For example, the first method, set position, calls the static method set position t : set position. The reason we have to specialize this way is that C++ doesn't let us specialize just one member of a class. And here we have the setter structs. The first 2 structs methods are unimplemented because they need to be specialized. The third does not, because we can always add another passenger. At least that's what the airlines would like to think. These are the specializations for the set position and set size structs. Each one is specialized with its corresponding flag set to false. If it's true, there is no specialization, and we can't set that field again. And here we have the build struct, which is called by the builder's build method, and its specialization, which requires all 3 flags to be true. The lines at the bottom are convenience definitions, so we can call make builder and call it set methods without having to write out the specialization details. So there you have it, a builder that enlists the compiler to keep you from violating the builder's contract. That's it.